Hi friends, this is Gautam. In this video tutorial, I am going to discuss about TCP header. So before going into this concept, you have to go through complete OSI layer concept. Then only you can able to understand the TCP header. So what I am saying in this video session. So we can see TCP. So the expansion of TCP is Transmission Control Protocol is a reliable transport protocol as it establishes a connection before sending any data, and everything that it sends is acknowledged by the receiver. So in OSI layer 4, transport layer, the TCP protocol will be coming under transport layer. So it's a reliable protocol. So reliable protocol means whatever we are sending the data, we will get an acknowledgement from the receiver side. Okay, so in this lesson we will take a closer look at the TCP header and its different fields. So this is the TCP header. So we have to go through each and every field. So how many bits are used and what is the use of that field. So everything we will go through in this lesson, in this video session. So source port, destination port, sequence number, acknowledgement number, data offset, resort bit field, flags, window, checksum, urgent pointer, option. So we can see. So first field is source port. So the source port is a 16-bit field that specifies the port number of the sender. So in OSI layer 4, we can use the port number. So in transport layer, we can use the port number. So 16-bit field. So 2 power 16 is 65,535. So in OSI video session, that time itself I told. So the port number range is 0 to 65,535. 0 to 1023 is a well-known port number. It's predefined. And 1024 to 49,151 is a registered port number. And 49,152 to 65,535 dynamic port number. So the dynamic port number, we can call it as a private port number. So we can use locally. So source port number specifies the sender of the port, specifies the port number of the sender. Next one, destination port. So destination port also same 16-bit field, specify the port number of the receiver. So for an example, destination port indicates what kind of applications we are requesting, we are going to use. So for an example, telnet means port number 23. If it's HTTP, the port number is 80. If it's HTTPS, the port number is 443. If it's POP3, port number is 110. So likewise. So next one is a sequence number. So the sequence number is a 32-bit field that indicates how much data is sent during TCP session. So during TCP session, how much of data we are transferred, we are sending. So using sequence number, we can indicates how much data is sent during the TCP session. So I will show it in example so you can able to understand what I'm saying. So when you establish a new TCP connection, that means the three-way handshake, then the initial sequence number is a random 32-bit value. So the sequence number is a random 32-bit field, 32-bit value in initial stage. So the sequence number is generated based upon the what kind of operating system we are using. So based upon that, randomly it will be generated in initial stage. So the receiver will use this sequence number and send back the acknowledgement. So receiver will use the sequence number, will send back the acknowledgement. So for an example, if they are sending sequence number 1, they will replying the acknowledgement. So based upon that sequence number. So next one, protocol analyzer. So protocol analyzer like Wireshark. So Wireshark tool. Using Wireshark tool, we can capture the TCP and we can analyze the packets. Okay, for the example for sequence number, let's say client A requesting 900 bytes of data from server 1. So once server 1 starts to send the actual data to client A, so the length of the payload of what is being sent directly influence the next sequence number. So let's say current sequence number is 1 and the server sends the client A 300 bytes. So first segment, the server can send 300 bytes of data to client A. So the original sequence number plus the amount of data in the payload that was just sent. So this means the sequence number will now be 301. So original sequence number is 1. Now server is going to send 300 bytes of data to client. So the original sequence number plus the amount of data we are going to send to the client. So 300. So 1 plus 300, 301 is a sequence number. So now let's say after client A acknowledges the first 300 bytes. So now the client acknowledges the server for the receiving 300 bytes of data. Now server 1 sends the 450 bytes data to client A. So the new sequence number will be 751. So previous sequence number is 301 plus now 450 bytes of data we are going to send. So 301 plus 450. So finally the sequence number will be 751. So finally server 1 sends what is the remaining. So last remaining is 150 because 900 bytes of data is requesting client from server. So first we can send 300 bytes, next we can send 450 bytes, the rest is 150. So this means the final sequence number would be 901. So 751 plus 150. So in this respect, the sequence number can be used to show the total amount of data that was transferred during TCP session. So each and everything I will show it in Wireshark so you can able to understand clearly. Okay, next field, acknowledgement number. This is 32-bit field is used by the receiver to request the next TCP segment. So this value will be the sequence number incremented by 1. So acknowledgement number is used by the receiver to request the sender for next TCP segment. So whenever we are receiving the sequence number, we have to acknowledge plus 1. So that's why they're mentioning here. So next to one, DO. So this is the 4-bit data offset field, also known as header length. It indicates the length of the TCP header. So it will indicates the length of the TCP header so that we know where the actual data begins. So the DO is a data offset, so it indicates the header length. So it looks like same like IP version 4 header. So this is 4-bit field. So the 4-bit binary representation is 0 to 15. So the minimum TCP header is 20 bytes and maximum is 60 bytes. So minimum 20 bytes means the decimal value is 5 into multiplier of 32. So 5 into 32 you will get 160 bits. So divided by 8 you will get 20 bytes. So same like 15, decimal value 15 into 32 you will get 480 bits, divided by 8 you will get 60 bytes. Same like IP version 4 header. So next one, RSV. So these are 3 bits for reserved bit. So these reserved bits are we are not using. So it's always set to 0. So next one, flags. There are 9 bits for flags. We also call them control bits. We use them to establish connection, send data and terminate connection. Okay, using this flag we can send the data. So we can establish the connection, send the data and terminate the connection. So the 9 bits for flag we can see. First one, URG. So URG is a urgent pointer. So when this bit is set, the data should be treated as a priority over other data. So when URG flag is set, so in the TCP segment, the data will give more priority than compared to other data. So next to flag is ACK, is used for acknowledgement. So TCP is a reliable. So whenever we can send that data, the receiver will give an acknowledgement for the data. So ACK is used for acknowledgement. So next to flag PSH. So this is a push function. So this tells an application that the data should be transmitted immediately. So for an example, for push function, when the when the sender and receiver, so the sender sends the data to the receiver. So during the TCP segment, the sender first of all send to its buffer. From that buffer it will send the data to the receiver. So the receiver will receive the data to that buffer, then afterwards the data will be moved to the upper layer, application layer. But using push flag, if that during the TCP segment the push flag is set as 1, means the data will send directly to the receiver without sending to the buffer. So the sender won't send to buffer, directly send to the receiver, and receiver move the data to the application layer. So where we can use this push flag means, for an example, telnet, because in telnet is used to access the remote device. So you can set username and password. So username, if you are giving the typing the character, so each and every character it will be stored in the buffer. From that buffer it will send to the receiver the buffer it will be received. So instead of that, push flag is set, so whenever we are typing it will be directly sent to the, immediately transferred to the receiver without sending to the buffer. So I will show it in Wireshark so you can understand where we can use this push function. So next flag, RST, this resets the connection. So when you receive this, you have to terminate the connection right away. Okay, so this is only used when there are unrecoverable errors, and it's not a normal way to finish the TCP connection. So when a receiver receives a TCP segment with reset flag is set na, so immediately the receiver will terminate the connection. So due to some unrecoverable error, so the TCP connection will be terminated for not. So not a normal way to finish the TCP connection. So next one, sync. So we use this for initial three-way handshake. So for initial three-way handshake, first packet we are sending sync. So you use it to set the initial sequence number. So next flags is fin. This is finish bit used to end the TCP connection. So how we can send the data? First we can initially establish the connection through the three-way handshake, then afterwards we are sending the data. Once finished sending the data, we have to terminate the connection. So you have to terminate the connection using finish bit. So that's why they're mentioning here. And TCP is a full duplex. Full duplex means two-way communication. So both parties, sender will send the fin bit and receiver will acknowledge for that fin bit, and receiver send the fin bit and sender will acknowledge that fin bit for receiver. Then only the TCP connection will be terminated. Okay, so next flag, explicit conjunction notification, conjunction window reduction, explicit conjunction notification echo. So these three flags we are not using nowadays. So these flags when we are using means from sender to receiver, if we are sending this segment TCP segment, so in between if there is any router, in that router interface have an conjecture, so that time that segment will be marked as an explicit conjunction notification, something like that, so the receiver will understand. So nowadays we are not using this one. So just for your understanding, I will just mention the rest of the three flags are there. So totally 9 flags. These three flags are not used often. We are not using these three flags. So next one, window. So window, this is a 16-bit window field, specifies how many bytes the receiver is willing to receive. Okay, the 16-bit window field specifies how many bytes the receiver is willing to receive. So the receiver will tell the sender how many bytes they are capable to receive the data. So for that reason we are using window. So it is used so the receiver can tell the sender that would like to receive more data than what is currently receiving. So for an example, sender sending 10 bytes of data to receiver. So receiver using window, they will send 15. So that means I am capable of receiving 15 bytes of data. So next time the sender will send 15 bytes of data. So likewise. So it does show by specifying the number of bytes beyond the sequence number in the acknowledgement field. So next field, checksum. So checksum, this is an 16 bits are used for checksum to check if the TCP header is okay or not. So same like in IP version 4 header also we can discuss about checksum. Same like in TCP header also, checksum is used to send the data. Either the receiver will receive as it is, the data received as it is from the sender. So the sender will use some algorithm to send some value to the receiver also using the same algorithm to check whether they will get any error or not. If there is no error, they are received as it is. If you are getting error, then receiver send the request for retransmit for that packet to the sender. So sender will retransmit the packet to the receiver. So next one, urgent pointer. So these 16 bits are used when the URG bit has been set. So the urgent pointer is used to indicate whether the urgent data ends. So urgent pointer is a 16-bit field. When the flag URG flag is set means, so the urgent pointer used to indicate where to start and where to end during the TCP segment. Where to start the data and where to end the data should be an more prioritized when compared to the other data. So for that reason we can use urgent pointer. So last one, option. So option is an optional field. Okay, so this is real time. I capture the packet using Wireshark. So here we can see what are the fields we are discussed in TCP header. I will mark it in red color mark. So first one we can see source port 41417 and destination port number 23. So this is a dynamic port number 41417. So destination port number 23 is a well-known port number. This indicates we are using telnet. So next one, sequence number 0, acknowledgement number 0, header length 24 bytes. Here flag, here we can see sync is set. This is a three-way handshake. First sync bit I capture. So window size value 4128 and checksum. So checksum value and urgent pointer. So and also I will show it to you Wireshark. I captured the telnet file. So here we can see telnet comes under TCP. So it's completely three-way handshake. So next one, telnet data. So in the telnet data I will click it. So in TCP, so in layer 4 in flag you can see push means it won't send to the buffer, it will send directly to the receiver also it will receive directly instead of receiving in buffer. So that time we are using push flag. So that's why I captured this file and I will show it to you. So in this video section, in this video comment section, so in description section I will give you one link, so you can click that link, you can download this Wireshark capture file and you can go through that file. So if you have any queries also, just you can ping me, I'll reply to your query. Okay friends, I hope you can understand this concept TCP header. So if you have any queries, please ping me, I will reply to your query, and please subscribe my channel for further updates and share to your friends also. So in next video session I will explain you the three-way handshake. So how the TCP three-way handshake will happen, how the TCP termination process will happen. So everything I will show it in Wireshark. We will discuss that concept. Thank you friends. Thank you for watching my video.